all that's
Good.
about. Okay, so let's go back one slide.
Okay, can you start over?
Yeah. Go back a few things, please.
Okay, all right.
No, forward, 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 forward. This one. All right, so here's where we are. This is basically taking everything that we've built up to so far and putting it all in one diagram. And note that this is sort of the folio-centric view. This is what you see on the folio side. So this does align with the sort of the Keycloak data model. And we've chosen names for things carefully because we don't want to use overloaded terms like permission, right? So that's why we introduced the term capability, because permission already is something that we know and it has a different meaning, right? Next. Here's the sort of corresponding view on the Keycloak side. You can see it is a little bit more complicated, especially with the policies here. But you also note that on the Keycloak data model, there is something called permission. It's something different. It's essentially the nexus of scopes, resources, and policies, as depicted here. And so what you haven't seen up to this point is I mentioned that we have like time-based policies. Well, there are other policies that are in use, but they're sort of hidden behind the scenes. Those are user-based policies and role-based policies. And so you can see here that there's a role-based policy connecting the role and the permission, which is equivalent to the capability in the folio side, right? And in the case where we're incorporating things like time-based policies, we have these aggregate policies that you can use and or operators to sort of combine these things together. And so this is not something you necessarily need to worry about. It's something that's sort of managed by the system. Next. And so here they are side by side, and they do sort of correlate left to right here. So a role in folio is equivalent to a role in Keycloak. Likewise for resources, actions, capabilities, and so forth.
Hand up.
Okay,
question.
Go ahead.
So the policy is the policy on the left side really on the left side, or is it technically on the right side of it?
It's so there's a policy record in folio for the time-based policy, and there's a corresponding record in Keycloak for that as well. Same thing with the roles, right? There's a role record in folio that corresponds to a role record in Keycloak. Next. Yeah. All right. So I mentioned earlier, what is system managed? What is user managed? And so for the system managed things, how does all this work, right? So what first? It's the capability sets, the capabilities, the resources and actions. And those of you that that attended the previous session, know that some of these things are, you probably know some of this already, right? But how well the necessary information is obtained from module descriptors, and we'll get into that in a little bit detail with some examples in a little bit. And this all relies on sort of adherence to well-known naming conventions and best practices. And modules, Keycloak does a lot of the heavy lifting here of keeping Keycloak and folio in sync with one another. We did this because backwards compatibility. The same module descriptors can be used on the Okapi-based platform as well as the Eureka platform. So we didn't have to change any schemas or anything like that to support this. And when timing of this is during tenant entitlement. So when you're enabling an application for a tenant, that's when these things get created. Next. So here's our example. You see it in the diagram up here. We have a capability. The action here is create, and the resource is user's item. So the capability is naturally user's item create. And in the bottom left here, we have a module descriptor snippet. At the top part, we have sort of the endpoint or handler portion of it. And that says, that tells us, okay, this is a post to /users, and the permission required is users.item.post. You can see I try to color code the things on the module descriptor on the left here and the capability record on the right. So this is what our capability looks like. You can see that we have a resource, in this case, user's item, and that's derived from users.item and the permission required. We have an action create that's derived from the .post. And then we also have other things in here that got pulled in from the module descriptor, including things like, the descriptor. The description is carried forward, as well as a reference to the permission that was used to create this capability. We'll use that a little bit later on. Next. So what does all this mean to the end user? I already mentioned how we have this, in the Okapi platform, we have this, this nested model with all these permissions. But in the UX, in the user interface, you basically have a flat list of permissions. So it's not really clear, what are you assigning when you assign someone, say, check out all permissions, right? You don't know what's underneath that. It could be a permission set that has a permission set that has all these other permissions, right? So conversely, in Eureka, next. We're managing roles, and we present that in sort of this grid view, right? So at the top here, we have the capability sets, and what's checked here is UI checkout.manage, which is equivalent to the .all, right? And when you select a capability set, the corresponding capabilities are automatically selected. So it's clear, it's easy to see. I selected UI checkout.manage, and here's what that user is getting, all these capabilities. So it makes it a lot more clear to what's actually being assigned to the user. A little bit of shifting gears here, but this is one of the questions this is maybe one of the most common questions that I get about Eureka is, what about our external system integrations? Whether those are via edge APIs or, just scripting or tools that interact directly with Okapi. And the TLDR is they should work with very minimal changes. So the edge APIs that use API key, those should continue to work without any changes. This is possible because we have introduced mod login Keycloak, which is a direct drop-in replacement for mod login. So it implements the same login interface. And so those edge modules, which basically call that login interface, continue to operate. It's just there's something different happening behind the scenes here. Now we're interacting with Keycloak. One thing that you do need to do is point to Kong instead of Okapi, right? So there's no Okapi in Eureka any longer. So for instance, in the edge APIs, there's this Okapi URL environment variable. Instead of pointing that to Okapi, you point it to Kong and you should be up and running, right? And then one more caveat down here is that credentials will need to be reset after migrating to Eureka. And of course, system operators that manage sort of the edge API institutional user credentials, they need to keep these in secret storage. So you need to as you reset your passwords, you need to make sure that you're also updating them there. Next. All right, so stripes and if permission. If you're not familiar with if permission, what it is, as it's defined in the stripes core README, a wrapper component that facilitates conditional rendering based on the existence of a permission. So in other words, if you've used Folio and you're familiar with the permission stuff, oftentimes buttons or action menu items or elements on the screen are shown or hidden based on the presence or absence of permissions assigned to that user, right? So again, the TLDR here is it continues to work in Eureka without any special provisions. And so how does that work? Well, in both platforms, it sort of works similarly where Stripes obtains this info after login by the self endpoint request that basically tells you, yeah, here's information about the person that just logged in, including all their permissions, right? There is some conditional logic on the interface here. So Stripes will look and see, is a user's Keycloak interface present? And if it is, it'll interact with mod user Keycloak self endpoint, right? Otherwise, it'll use the standard self endpoint provided by mod users BL. And if using the mod users Keycloak in that scenario, the permissions that are associated with the capabilities assigned to the user, either directly assigned to the user or assigned via roles, will be present. So that's why, if you remember when I was showing you the capability, that's why we maintain that sort of reference back to the permission that was used to generate that capability. So we basically just say, all right, give me all this user's capabilities, gather up all those permissions and stick them in the response to the self endpoint. All right, moving on to module sidecars, another big sort of topic that wasn't presented last year. Next. So why do we need sidecars? With the Okapi-based platform, authorization is performed by Okapi, right? Sort of orchestrated by Okapi by interacting with mod auth token, mod permissions, and so forth. Every call in the Okapi platform goes through Okapi, right? So it's a logical place to put it. But where we split up the responsibilities in Eureka to Kong as an API gateway and Keycloak as identity and access management, we need a place, some hook, some place to do this authorization. And so that's why we introduced a sidecar, also to perform tenant entitlement checks. Is this application enabled for the tenant, essentially, right? It also serves as a convenient place to do things like structured transaction log, something that doesn't really come out of the box with Folio today. I mean, it's possible with like things like Nginx and whatever else, but having structured transaction logging can be really helpful. Also, it gives us a place where we can obtain and inject system user credentials or access tokens, rather. And we'll drill into each of these things in a little bit here. And finally, having these sidecars, which are essentially just a component that sits really close to each of the module containers. It allows us to do module-to-module requests without going through the API gateway. So the sidecars know how to route requests between one another. Sorry. No, I'm ready. That's good. All right. So before we get into the details of any of that, I wanted to touch on the technology selection. So we chose to use Quarkus and build the sidecars on top of Quarkus, which is a Java framework. One of the things that made it attractive to us is that you can compile it to native binaries. And that allows you to shrink the memory footprint of these significantly, which is really important because we're going to be running these things all over the place. It also provides some performance benefits, things like faster boot up times and so forth. We did evaluate other technologies, specifically Envoy and Spring Native, and here's some of the criteria that we used during that evaluation. So, is it easy to use? What is the quality of the documentation? How mature is the project? Community activity, resource consumption, integration effort, and then logging and observability. So for Envoy, we didn't go with that because it wasn't as flexible as we wanted it to be. And where it was flexible, we relied on Lua, a language that isn't commonly used in the Folio ecosystem. And I don't think you can compile that to native binaries. I might be wrong in that last point. But for Spring Native, we chose not to go that route because at the time it was still in beta state. And one of the other things that made it kind of awkward was it often required sort of extensive use of annotations in the code to enable the compiling to native. So it was a logical choice to go with Quarkus, and I think we're happy with our decision. So before I get into anything else on the sidecars, I wanted to introduce the concept of ingress and egress requests because I use those words later in the presentation. Yeah. So all requests, whether they're going into the module or outside or out of the module, pass through the sidecar, right? So in ingress one, you guys are all familiar with that. That's when you're calling an API in the module that passes through the sidecar, and the sidecar performs some flows like that's where it does the tenant entitlement checks I was mentioning earlier. Basically, is this module enabled for the tenant? This is also where we enforce authorization. Does the user that's making this call have sufficient privileges to do so? On the egress request side, that's when the module is maybe calling another module. And so the request processing there is slightly different. The things concerned here are consulting discovery to route the request to the appropriate place. So the sidecars need to know where to send the request. Also, I touched on this a little bit earlier, but system users, if needed, we can, the sidecars are a good place to sort of decorate those egress requests with the access token of a system user. And there's a section specifically on that a little bit. So this diagram may be a little bit confusing, but it's showing that, for instance, you get a request may come into the sidecar. That's an ingress request going to the module. That's where we're doing the ingress request processing. And if that module then needs to call another module, that would be an egress request again going through the sidecar. And it's where we're doing these the processing for request routing and system users. And so you notice that there isn't a line directly from module to module, even though we refer to it as module to module communication. It's really going from sidecar to sidecar. So I wanted to make sure that that's clear. Next. All right, so how do sidecars know how to route requests? So I mentioned that sidecars need to know where other services live, otherwise they wouldn't know how to route the requests, right? So there are two parts to this. At startup, the sidecars interact with the manager services that Alexei talked about in his previous presentation. to get some information about the entitlements, which tenants are entitled to use this module, also information about the module itself and the endpoints that it provides, and finally, discovery information about modules that this one depends on, right? So, and then later on, once everything's up and running, the sidecars receive updates from these manager services via Kafka. If a new application is enabled or disabled, the sidecars need to know about that because they're enforcing these tenant checks. If some discovery information has changed, they need to know about that so they can route the request properly. So that's the sort of the left-hand side of this diagram. So a couple important pieces I wanted to point out is that the discovery information that's obtained the sidecars don't pull in all the discovery information. That's a lot of info. And again, we're trying to keep the memory footprint small on these. So we only retrieve the discovery information that's required. And how do we know what's required? Well, we again rely on the information in the module descriptors. In this case, it's the interface dependencies. So we only retrieve discovery information from modules that provide the interfaces that their associated module depends on. So that means if there are missing dependencies in your module descriptor, that's going to screw things up, right? That's going to be a problem. And we actually saw that when we first started using this stuff. And we were able to identify several places where there were missing dependencies. And so it became clear we need to do something to sort of ease the transition into that. So we introduced this compatibility mode. It's a feature flag in the sidecar. When it's enabled, it essentially says, if the sidecar doesn't know how to route a request, just send it to Kong. Kong will know how to route it. It's not the ideal path for a request, but it will allow the system to continue functioning. And maybe the most important part here is that we log a warning so that you can go back after and identify the missing dependencies so you can then go and fix these things up. So maybe it's good after you run a bunch of automated tests or manual tests to go look at the logs for that particular message and see, oh, okay, yeah, these are, the request succeeded, everything's working, but maybe the performance might have been a little bit slower because you need to go out through Kong and then back in and all this other stuff. So I think that's it for us. Next. All right, authorization and entitlement checks. I think this is fairly straightforward. So a request comes into the sidecar and it needs to know, is this module enabled for the tenant? That's easy. It has that information in memory, right? So it can do that check fairly easily. But as far as the authorization part, it basically takes information from the request context. So the endpoint that's being called, the access token, the tenant, and so forth. It sends that to the Keycloak introspection API, and then Keycloak responds with yes or no, right? And if it's a no, the sidecar responds to the request with a 403 or 401, depending on the circumstance. And if it gets a positive response from Keycloak, then it forwards the request to the module. There's also some caching that's happening here, so that to sort of reduce the chattiness between the sidecars and Keycloak, because this stuff is happening on every single API call. Caching is important here. And so in order to make sure that we're not allowing things, we're not authorizing calls based on cache entries after a user is logged out, we're again relying on Kafka to inform the sidecars of logout events. So when a user logs out, a message is sent to Kafka, and the sidecars consume that and say, okay, yeah, I need to invalidate these entries in my cache. Next. Right, platform managed system users. I know I'm flying through this, but we lost a lot of time. So, so the problem statement here is that in order to support background operations, we've noticed this trend in the community where many modules are introducing logic to build, to create, and sort of use system users, right? We've seen this in a bunch of different places. It's not great. So that means there's like repeated code over and over again. Mod search might do it in one way, and then some other module might do it in a different way. But we're sort of duplicating that code for creating a user, creating credentials, and assigning them permissions and so forth, right? So this leads to this sort of proliferation of dependencies on interfaces, which the modules are typically not used anyway, right? So mod search would never use the login interface or permissions or users, right? But since they have to create and manage these system users, now they have these additional dependencies. So we all know the dependency tree in Okapi in Folio is tricky. It's tangled. And so if we could simplify that by removing some of this, well, that's great. And finally, it places the burden on system operators. They need to ensure that they're managing these system user credentials, they're storing them in a secure way and passing them into the modules in a secure way. And in fact, we ran into a situation, I think it was just this last year, where we found out that some modules, some people hosting or running Folio were actually not specifying system user passwords. They were relying on the defaults, which is not a great idea, right? Because that's public information. And in at least one of those cases, the system user had privileges to see like user data, including like personal data. So that was a bad thing. It's another reason why having the system manage this stuff for you is a great benefit. So one quick example is mod search. It receives a notification from Kafka that something in inventory has been updated or created, and it needs to incorporate that into its search index. So since there isn't a request context there, it needs to rely on a system user to do that, right? So that's one example. And as the time of, because Nelly, I know you can't see the last part of this, but there were 9 of these modules that were doing this sort of thing. Next. So how do we solve it? We basically we introduced a mechanism allowing modules to declaratively specify that they need a system user or a tenant level user and what their privileges are. It's fully managed by the system. So modules can deprecate and eventually remove that logic that they have for creating, managing, and using system users. And this is more secure because sysops don't need to worry about storing and specifying credentials. The system actually stores them in a secure store and retrieves them as needed. So less work for sysops as well. Of course, it reduces that code duplication and reduces the number of dependencies in the system, which is nice. It's worth noting that this is all backwards compatible. We're leveraging fields and properties in the modular descriptor schema that are already there. We didn't have to change the schema in order to support this. And feature flags have been introduced to those 9 modules that I mentioned earlier to allow you to opt in to disabling the creation and use of those system users. And that would be something that you would do when you're running on Eureka. But if you're running on the Okapi platform, then you don't want to disable those system users in from Park. And finally, this is also applicable for edge modules. So I think I mentioned earlier in the presentation that sysops currently provisions and maintains these institutional users for their edge modules, and that's all manual work that happens outside of Folio. You could specify a tenant level user in the module descriptor for these edge modules and rely on the same mechanism for managing these things. So here's a few more details. Here's actually a snippet from the mod search module descriptor. You can see it's in the metadata section of the module descriptor, and underneath that we have user. It's a type system, so this is a system user, and here are the permissions that you need to assign to it. So trying not to repeat myself here. Right, so when a module, this is all managed by the system, and the sidecars play a role here as well. In sort of injecting or decorating that response, decorating the request in that module to modules case, right? And so how do the sidecars know if they need to do this? Well, we rely on the absence of exocopy user ID. So when a sidecar gets an egress request, so a request from its associated module going outwards that is missing this exocopy user ID request header, that's an indicator to the sidecar that if I know about a system user, I should probably inject it here, right? So it obtains the credentials from secret storage, it obtains an access token, caches some of that stuff, of course, and then adds that to the request before proxying it. Next. All right, auth users and users. So a little bit of a context change here, but when we introduced Keycloak into Eureka, it was immediately clear that we need to store some information about the user in Keycloak, right? And I think there was a question about this in the last session, but we're referring to user records in Keycloak as auth users, and that's just to keep them distinct from user records in Folio. Basically, the information in Keycloak, the auth user records, is all about users of the system. So people that log in and actually use Folio. So that's why they need a presence in Keycloak, which is performing the authentication and authorization flows, right? So that's like librarians, staff, and administrators. The information stored there, an ID, a username, some basic metadata, maybe an email address. This is where role assignments are stored, credentials, identity provider links, that sort of stuff. Anything that's auth related is stored in Key. On the Folio side, we still have the same user records that you guys are familiar with, right? So things like patron groups, default service points, external system IDs, all that stuff still lives on Folio. This is all about users in the system. So essentially, users in this case are just data in the system, right? And so it's not just librarians, admins, and staff, but also patrons, and maybe there are other, system users, whatever it is, right? There's probably other groups that I didn't list here. And so if it wasn't clear, these two records are associated with one another. And this little mini Venn diagram here indicates that auth users are a subset of users, right? So not every user in the system needs to log in and use it. That's fine. But those that do need to, they get an auth user record. Go ahead, Ian.
Are the system users that you were talking about previously that are managed by all this, are those a kind of auth user, or are they separate from?
They would have a user record in mod users, and they would also have an auth user record. Yep. Next. All right, so continue on this. So auth users are managed by, so this is all managed by a Folio. You don't have to log into Keycloak admin console and muck around or anything like that. In fact, it's fairly seamless. So we introduced this notion of promoting a user to an auth user. So that might happen in certain circumstances, like when you're assigning a user credentials, there's a check that happens now that says, okay, is there an auth user record for this person? Because the credentials are stored in Keycloak. I can't store something in Keycloak if there's no user record, right? Likewise, if you're trying to assign roles to a user or capabilities directly, right? And so by promoting a user to an auth user, it basically means that we're creating the auth user record in Keycloak for on an as needed basis. We've also introduced migration APIs to sort of ease the transition into this. So there are two of them. The user migration one is basically responsible for creating auth user records as needed. So how do we know which users in sort of the source environment need to be sort of promoted to auth users? We basically look for any users that have at least one permission assigned to them. Because if you don't have any permissions assigned to you, you're probably just a user in the system, not a user of the system. The second migration API is for role management, role migration. And for this, we look at that same set of users that we just migrated for in the user migration. And we look at the unique set of permissions that they have across them. And hopefully there's some overlap, right? There are maybe a handful of users that have the same set of permissions assigned to them. And so basically we create a role for each unique set of permissions. And so we acknowledge that the roles created in this way are not going to be ideal. They're going to have system generated names. In many cases, you're probably going to want to refine those and clean them up a bit and maybe split them up in some cases or possibly even combine them. But the intent of the migration APIs is to allow you to get to a point where if you had a user in the system that was able to do check-in and check-out, that after you run these migration APIs, that same user in the Eureka platform would still be able to do check-in and check-out, right? Question in the back, and then you, Todd.
If regular patrons don't have permissions and they don't get the old user information, where will the PIN codes or passwords for the new access be stored?
So PIN codes, I mean, that's an interesting one. I think PIN codes are actually part of the user record and in Folio in the mod user side.
We are using the password field at the moment. So.
Password, right? So the password credit. So I mean, are you suggesting that you have a user that doesn't have any permissions but has a password?
Yeah.
For what purpose?
To log into our SIP2.
Okay. So in that case, when you assign credentials to that user, they would be promoted to an auth user, right? And I think I mentioned that on the previous slide, or actually, it's right here on the slide. So when assigning credentials. right? So, and I mentioned earlier that when you're moving to Eureka, the credentials are not migrated for you, and that actually might be here. It's down here, yeah. And the reason for that is because the passwords in Folio are salted and hashed. The plain text password is not stored. So you can't reverse that. You can't go back and you can't get the plain text password to then set your credentials in Keycloak, for instance. So I think when you perform the migration and you set the credentials for those users, an auth user record would be created for you. Jens?
By saying with users with permissions, you mean with a permissioned user record?
That's right.
Or with a non-empty permissioned user record?
I don't know, actually. It's possible to have an empty permission user. Yeah, go ahead, Alex.
So, yeah, we are looking for assigned permission. So even if we have a user permission record, but doesn't contain any information about permission assigned, so we did not increase.
So they would not be created if you create them with empty permission set for the.
Yeah, they wouldn't be migrated as part of the UI, sorry, as part of this user migration, but they would get an auth user record when you set their credentials. Okay, I think that's it for this slide. Oh, sorry, we did have more questions. Go ahead, Todd.
Some of us have already been creating roles, modeling roles through permission sets, permission sets. Will the role migration be looking at custom permission sets and recreating those? Or just aggregating them at their user level?
Right, so we've introduced the notion of like reference data or like default roles that come with the system, right? So just like we have reference data for inventory storage or anything else. And those are based off of those permission sets that you're referring to, that are actually named things like acquisition manager role and things like that. So if you're a system operator and you're standing up a system, if you say, load reference data, you'll get those default roles out of the box. And they'll be named appropriately. They won't have like the funky system generated stuff or anything like that. Go ahead, Rick.
I think Todd is talking about a migration path for those.
Yeah, so we have internally created thing like a permission set, say for.
Oh, your user-defined permission set.
Right.
Yeah.
Worker or somebody.
But so the algorithm should find them, right? Because there's commonality. So if you assign them to a number of users, the algorithm identifies that and will system generate a role, give it maybe a different name, but.
Right. Yeah. So I mean, it won't carry forward the permission set itself, the user-defined permission set, but it will create a role based on the unique set of underlying permissions, right? It'll sort of flatten it down and assign those corresponding capabilities to the system generated role.
Great, thank you.
So I kind of let's hold off on additional questions until we get through the rest of the material. Sorry, Ian. Okay, well, we're almost there. I didn't realize. So, in summary, so we made a lot of progress since last year at WOLFcon. We presented concepts and ideas last year. We went through proof of concepts, some technology selection and so forth, and have implemented this stuff. So great progress there. There are many benefits, security and auth related benefits to using Eureka. A lot of that's provided directly by Keycloak, but also the sidecars enable some of that as well. And one of the themes that you might have noticed throughout this presentation is we've tried to make the transition to Eureka as easy as possible by maintaining backwards compatibility and also introducing migration APIs and things like that, making it so there aren't breaking changes in schemas and all that stuff. So 2 of the 3 sessions mentioned here, if you're interested in learning more about Eureka, 2 of them have already passed, but they were recorded, so you guys can check those out afterwards, and the slide deck should be made public as well. And then tomorrow we have an application formalization workshop, which won't really cover a lot of the auth related stuff that was in this presentation today, but is Eureka related. So I think that's it. And now, how much time do we have for questions?
Minus 2 minutes.
Minus 2 minutes. All right. Ian, you had your hand up?
Is there a user demotion process?
Not yet. Yeah, that's something that's on our radar. We need to come up with something for that. We just haven't implemented anything yet.
That's only if users have a lot of outstanding fines.
Anyone else?
Yeah.
Go ahead.
Yeah, still something it's not clear to me. You said that capabilities can be defined with permissions.
Mhm.
Can they also use permission sets?
Right, so capabilities are derived from permissions. Capability sets are derived from permission sets. So, I probably could have made that a little bit more clear in the presentation.
Oh. So if a module has a number of permission sets that are using other permission sets and so on, with a nice hierarchy, this is going to be all flattened new system.
That's right, yep.
Okay. Well, I mean, it's not really well flattened because you said you can use permission sets with capability sets. So you can have a permission set that defined with permission sets that is then being used by a capability set, right?
Yes,
Go ahead, Alex.
I can answer that. So, when we are creating a capability set, we recursively loading all permissions that include to this capability set, make flattened list of unique things, and finding appropriate capabilities. And this capability set should include a flat list of capabilities that have this capability. I mean that based on permission, root permission set, we're loading all unique children, and make a flat list of these things and finding corresponding capabilities and include it into the capability set. Capability set is always a flat list. No error.
Okay, but
Capability
the permission sets that are defined currently in the module descriptors can still be used. Right?
yes.
They don't.
So, yeah, so
Created.
user-defined permission sets are not carried forward as capability sets. Only the ones in the module descriptors are, right? So like UI modules oftentimes, I think all the time, define permission sets that include those fine-grained permissions that are defined by backend modules. That's sort of the pattern that's followed here, right? And so for those permission sets that are defined in module descriptors, we create a capability set, and that capability set is comprised of the sort of constituent capabilities associated with the permissions included in that permission set. Do you understand what I'm saying? So if a permission set, users.all or something like that, right? Where you're able to do the basic CRUD operations on users, right? And that includes the underlying permissions for users.get, users.post, delete, whatever, right? We would end up creating a capability set for users.all, right? And the underlying capabilities would be for users.get, users.post, users, and so forth.
And it wouldn't matter how many levels of hierarchy you have between them.
That's right. Yep. It flattens it before doing that. Yep.
Yeah.
Because
that means, for instance, for backend modules, you can still have permission sets in the module descriptor, but it's not deprecated.
I think I didn't quite understand that last part.
If there are permission sets of permission sets,
Mhm.
backend module descriptor.
Nested.
This is not getting deprecated, where you can still.
You can still do that.
Permissions
It'll get flattened out. Yeah, you can still do that. It'll just get flattened out and when it's mapped to the capabilities and capability sets.
Okay.
Question online here.
Oh,
Question online. So could Keycloak be used as OpenID provider, for example, for ViewFind?
that's an interesting question. I think I don't know much about ViewFind, so I don't know how to really answer that. But Keycloak could be shared with. You could use Keycloak. You could share an instance of Keycloak with Folio and other applications. I don't see a technical reason why that wouldn't work.
We're doing that with Locate as well.
Yep. So yeah, I think in theory the answer is yes.
I think the big problem with WOLFcon being it's for the patrons to use.
Mhm.
So that's where the point where you have to have patron credentials.
Yes.
Right. Yeah. So yeah, I don't know how that would be represented if you would have to create a separate realm for ViewFind and have all your patrons in there. That's essentially what Locate is doing, is it has a separate realm.
Yeah, they can
Todd,
here not to touch all the things created by Eureka manager components,
because
Yeah, you gotta be careful if you're having multiple applications share Keycloak that that they're not stepping on each other's toes, right? And that'd be really bad. Go ahead, Todd.
Maybe the question is, what in the SSO context, what role is Keycloak playing in Folio? Is it acting as a service provider or as an identity provider? I think it's a service provider.
And for SAML too, it's a SP, right? It's a service provider that's interacting with some external identity provider, right? For OpenID Connect, which is being used for the quote unquote native authentication, it's acting as the identity provider there.
Okay.
Yeah.
Okay. Because the question with Viewfind is what you're using as your identity provider and what are you using as a service provider?
Mm-hmm. Right. Go ahead.
My question is, how much Folio Keycloak differs from base Keycloak source code? Because many libraries are already using Keycloak for many purposes, and even they are using forks for purpose. For example, federation, game federation, and a lot of other things. So, did you make some major changes in Keycloak, or it's vanilla pure version?
It's fairly close. So there's a GitHub repo called folio-keycloak. And we're pretty much just pulling in the base image from Keycloak. What we've added are a couple themes so that the login screen provided by Keycloak is familiar to you guys, right? So it doesn't look like something foreign. It looks exactly or as close to the login screen that you have on the Okapi platform, right? But we've also incorporated, I think, just one plugin, right, for doing that automatic linking of identity provider to user. And so, I mean, you could use that or you could not use that. It depends on your use case.
That's a new question. Zoom, new question.
What sort of implications does this have on ECS folio environments? So that's referring to enhanced consortial support, I think. So ECS seems to only support a single IDP. Does the introduction of Keycloak potentially allow for the use of multiple IDPs for folio auth? It does. I don't understand the part where it says currently ECS seems to only support a single IDP. I think that's Folio on the Okapi platform only supports a single identity provider. Maybe that's what you're referring to. But with Keycloak, you could have as many as you want. And those basically show up as distinct buttons on the login screen underneath the standard forms, username and password. And we'll say like, maybe we'll say like auth0 or
but a federation, making federation in Keycloak differs from, for example, Shibboleth or other identity providers system, and it's not. Keycloak is not meant to be a federation system or. The purpose is a little different. Capability for federations are very are not supported as well as you expect if you want to do these things in people.
Yeah,
This is the reason why many libraries are forking Keycloak and other features and capabilities.
I can answer here. So, Keycloak do not know anything about consortia stuff. So, consortia performs on Eureka platform in the same way as it performs in regular installation. We have some specific code base inside of most consortia Keycloak. And some things inside car can handle this multi-tenant requests. But Keycloak do not know anything about consortia. It performs only, okay, can the user do this thing? Yeah. And it's a little bit more complex and maybe another topic for another conversation, but yes, we are supporting consortia stuff. No, Keycloak do not know anything about consortia and we using
Those are just secret rules in Keycloak and all the magic happens inside.
and not consortia.
A really good question,
Mhm.
in relation to supporting multiple IDPs, is there a limit to how many?
Not that I'm aware of.
Okay.
I think it would get a little bit clunky if you had dozens of them on the screen, but, I don't think there's a technical limitation there.
Okay,
And that you can customize, like I said, via themes, the login screen, so maybe, I don't know if this is possible, maybe there'd be, you could replace the buttons with like a drop-down list or something like that to make the user interface a little bit nicer. Go ahead.
There is the where are you from? It's WAYF of DFN, which is basically a drop-down menu for multiple XAML authentication providers used in this federated system.
Okay.
Yeah, I know that Keycloak provides sort of login hints as well that helps you identify.
Just throw over time here.
Okay, yeah, so I think that's it. Thank you guys. And feel free to reach out to Vince Rye if you have any questions.